Hey everybody, Chris McClure here. We're now going to take a look at quadratic equations. Last time we were looking at linear equations that basically said we had a linear polynomial set equal to 0, and then we solved for the variable. But now we have a second degree polynomial set equal to 0, and we will solve for the variable x. Now, a, b, and c are constants, of course. We have a second degree polynomial, so we should expect to have up to, but no more than, 2 unique solutions. But we could possibly have 0 or 1 solution, depending on, of course, the coefficients of a, b, and c. Now, remember, the graph of a second degree polynomial is a parabola. So we could have our parabola where the minimum is greater than 0, in which case we would have no solution. Or we could have our parabola come down and just touch the x-axis just once, and that would correspond to there being 1 solution. Otherwise, your parabola could dip down and then back up below the x-axis, in which case you would have 2 unique real solutions. We talk about real solutions. Now, a quadratic equation always has 2 solutions. It's just a matter of, are they real or are they complex? Or if we say that there's 1 solution, it could be that there's 2 solutions, but they are not unique. They're just the same value, in which case we just say that there's 1 unique solution. So we'll sort through that as we work through this section. All right, so we're going to look at some different techniques of solving a quadratic equation. And this first technique is the factoring. Now, we know how to factor a polynomial now. We've already gone through that section in review in chapter R. So what we do is we take our equation and make sure that you move all of the non-zero terms over to the left-hand side and arrange your polynomial from the largest degree to the smallest, and then factor it. Now, for this particular example, we can factor this as x times x minus 4, and then invoke the zero factor property. The zero factor property basically says is if you have one factor times another factor equal to 0, then at least one of these 2 factors is equal to 0. So what we do in algebra is we set both of those factors individually equal to 0. So we set x equal to 0, and we set x minus 4 equal to 0. Now, if x minus 4 is equal to 0, that's the same thing as saying that x equals 0. So we have 2 solutions, 0 and 4. We will sometimes talk about a solution set, which is just a set of numbers consisting of the solutions. And we'll write those numbers within a pair of curly braces, like you see there. So the solution set is 0 and 4. Okay, moving on here. Moving on. All right, so here's another example here. This time we have to rearrange this so that all of the terms are moved over to the left-hand side. So we will add the x and subtract the 6 over to the left-hand side, so we now have a second degree polynomial set equal to 0. And then we could factor x squared plus x minus 6 as x plus 3 times x minus 2. And set each one of these factors equal to 0. And if x plus 3 is equal to 0, that means x is equal to negative 3. And if x minus 2 is equal to 0, that means x equals 2. So you have your 2 solutions, negative 3 and positive 2. So there's your solution set. moving along here. Now, if you just have the equation that your variable squared is equal to some non-negative number, such as x squared is equal to p, then you could simply solve this equation by moving the p over to the left-hand side of the equation and then factor this as x minus the square root of p times x plus the square root of p is equal to 0. And that means x is equal to square root of p and x is equal to negative square root of p. So in other words, x is equal to plus or minus square root of p. So if x squared is equal to 7, that must mean that x is plus or minus the square root of 7. If you have x plus 3 squared is equal to 9, there's really no need for you to FOIL out the x plus 3 squared and then subtract 9 from both sides and then using some weird method to solve your equation. You could just simply say, well, x plus 3 must be equal to plus or minus square root of 9, which is 3. So that means that you have x plus 3 is equal to 3 as one possible solution, in which means that x is equal to 0. Or you could have x plus 3 is equal to negative 3, in which case you have x is equal to negative 6. So you have two solutions, 0 and negative 6. Okay? So 0 and negative 6. Alright, moving along here. Let's talk about completing the square. So I think we remember how to complete the square, right? It's just something that you add to a square term together with a linear term in order to form an expression which is the square of some binomial. So let's take a look how we do this. We have the equation 2x squared plus 6x minus 5 equals 0. And so what we'll do is we will add the 5 to the other side, and then you have 2x squared plus 6x on the left. Let's do what we have to do in order to get rid of that leading coefficient that's not equal to 1, namely divide both sides by 2. So divide both sides by 2, so now you have x squared plus 3x. Now, if you remember from chapter R, how to complete the square is you take a look at the coefficient of the x term, which in this case is 3. Take half of that, which is 3 halves, and you square 3 halves, which gives you 9 fourths. So you're going to add 9 fourths to both sides of this equation, and now what you have for x squared plus 3x plus 9 fourths is x plus 3 halves squared. And on the right, 5 halves plus 9 fourths. You could write then 5 halves as 10 fourths plus 9 fourths is 19 fourths. And now then you can just say that x plus 3 halves is equal to plus or minus the square root of 19 fourths. Or in other words, plus or minus square root of 19 over 2. And then you could subtract the 3 halves from both sides, so you get x is equal to plus or minus square root of 19 over 2 minus 3 halves. No, so you could have square root of 19 halves minus 3 halves, which will give you square root of 19 minus 3 over 2. Or you could have negative 19, or square root of 19 minus 3 over 2. Or if you want to pull out the negative sign, you'll have negative of square root of 19 plus 3 over 2. Those are the small little typo on the slide there. I obscured. But anyway, so there's your two solutions there. This one and this one. Okay. Now let's talk about solving the quadratic equation using the quadratic formula. Now, I am going to derive the quadratic formula with you right now. So pull out a piece of scratch paper and let's go through this together. I'm going to pull out my journal here. So go ahead and let's do this together. We have ax squared plus bx plus c is equal to 0. And we are going to complete the square. So we're going to follow a sequence of steps so that we end up with the quadratic formula, which says that x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. So how do we get from here down to here? Well, I'll tell you, I'm glad that you asked the question. Subtract c from both sides up here. So we have ax squared plus bx is equal to negative c. Now divide both sides by a. So you have x squared plus b over a x is equal to negative c over a. And then take a look at this linear coefficient, b over a. Take half of that, and that's going to be b over 2a. Square it, and that's what you'll add to both sides. So you have x squared plus b over ax plus, and here we're completing the square, and b over 2a squared minus c over a. Now on the left-hand side we have x plus b over 2a squared, and on the right-hand side we have b squared over 4a minus, and then to get a common denominator for the second fraction here, we'll multiply by, 4 and a. So 4ac over 4a squared. Or in other words, b squared minus 4ac over 4a squared. And then take square roots of both sides, so you have x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac over 4a squared. Well, we could take the square root of your b squared minus 4ac, and of course the square root of 4a squared there in the denominator is just your 2a, and of course subtract your b over 2a over to the right hand side, and you've got, voila, your quadratic formula. Okay? So there you could do a magic trick at the next party you go to. Probably wouldn't be very popular, but hey, now you know you can do it. So you've got this quadratic equation. A, b, and c are just numbers, and x is your variable, assuming that the leading coefficient is not 0. So you have a bona fide quadratic equation. And here's your quadratic formula right there. Now this term under the square root sign is called the discriminant. The b squared minus 4ac is the discriminant. Now if the b squared minus 4ac, the discriminant, is negative, well, can you take the square root of a negative number and still get real numbers? The answer is no. So what this is saying is that the discriminant is 0, is less than 0. I mean, that's the same thing as saying that your quadratic equation has no real solutions. Now, if b squared minus 4ac is equal to 0, if the discriminant is 0, then the square root of that is 0 as well, and you just have the one unique solution, negative b over 2a. Otherwise, if the discriminant is a positive number, greater than 0, then you're going to end up with two different real number solutions. Okay, so that's basically all summarized on this panel. So the value of the discriminant, whether it's negative 0 or positive will determine whether you have any solutions, and if so, how many. Either you'll have 0 solutions. In this last case, you'll have one unique solution in the middle case and two unique solutions in the first case. So let's put this to some use. Here we have 2x squared minus 4x plus 1. So you identify A as 2, B as negative 4, and C is equal to 1. And you can just plug those numbers into your quadratic formula. So let's go ahead and calculate our discriminant first. B squared minus 4AC. Well, B squared is going to be negative 4 squared, which is 16, minus 4 times 2 times C. So you have 16 minus 8, and that's positive. So we know that there are two real solutions. Okay? So we have our discriminant, and it's 8. So we have negative b, but b is equal to negative 4, so we have negative of negative 4 plus or minus the square root of 8 over 2 times 2. Or in other words, 4 plus or minus square root of 8 over 4. Now, remember, we can simplify square root of 8 by pulling out a 4, which will give you 2 times the square root of 2. Then you can cancel a factor of 2 from the numerator and the denominator, leaving you with 2 plus square root of 2 over 2 as one solution, and 2 minus the square root of 2 over 2 as a different solution. So there's your solution set. Okay, moving on. Here is another example. Now look, when you have an equation where you have fractions as coefficients, then you're going to want to clear those fractions by multiplying through by the least common multiple of the denominators. In this case, you just have the one solution 2, or the one fraction with the denominator of 2. So multiply both sides of this equation by 2. And when you do that, you just have 1x squared minus 12x plus 36 equals 0. And now you're in business, and now you just have integers as coefficients, and then go ahead and plug those numbers into your quadratic formula. Here a is 1, b is negative 12, c is 36. So plug those numbers into the quadratic formula. Before we do that, though, let's just take a quick look at our discriminant, b squared minus 4ac. Now b squared is 144 minus 4 times 1 times 36. Well, 4 times 36 is 144 as well. 144 minus 144 is 0. The discriminant is 0, so that means that there's only going to be one unique solution, and that's going to be negative b over 2a. In other words, 12 over 2, which is 6. So 6 is the one unique solution, and your solution set just consists of the one number 6. Okay, moving along here. Here's our next example here. 2x squared plus 3 is equal to 2x. Subtract the 2x over to the left-hand side. All right, and notice that, of course, we have our terms in descending order for their powers. A is 2, B is negative 2, C is 3. Plug those numbers in for the discriminant. B squared minus 4ac is negative 2 squared minus 4ac, so negative 4 times 2 times 3. So that's 4 minus 24, which is negative 20. Your discriminant is negative here, which means that you don't have any real solutions, because you cannot take the square root of negative numbers. Moving on here. Here's yet another example. This does not look like a quadratic equation. But if you were to multiply both sides of the equation by x squared, then you'll have 6x squared plus x minus 2 equals 0. Now we'll just have to make sure that 0 is not a solution, because in the original equation, for both of these fractions, x cannot be equal to 0. So we have 6x squared plus x minus 2. Let's go ahead and plug those numbers in, the 6, the 1, and the negative 2 for a, b, and c respectively, into the quadratic equation. Quadratic formula, I mean. Now looking at the discriminant, we have b squared minus 4ac. So that's 1 squared minus 4 times 6 times negative 2, which is 1 plus 48, which is 49. Our discriminant is positive. That means we'll have two unique solutions. So according to the quadratic formula, we have x is equal to negative b, which is negative 1 plus or minus the square root of the discriminant, which is 49, divided by 2a, which is 2 times 6, which is 12. Simplify. So, but square root of 49 is 7, so you have negative 1 plus 7 over 12, which will give you 6 over 12, which is 1/2. And you'll also have negative 1 minus 7 over 12. So negative 8 over 12, which is negative 2/3. So you have your two solutions, 1/2 and negative 2/3. So there are your two solutions. There's your solution set. Now, again, make sure that when you go back to the original equation, if you were to plug these numbers in, both of these numbers individually will solve this equation, a guarantee. Just make sure that the expression on the left is not undefined at either one of those numbers, which we're good in this case because neither one of those numbers is 0. So you see, here's your step for solving your quadratic equation, and using the quadratic formula, identify your coefficients a, b, and c. Take a look at your discriminant. Is it positive, negative, or 0? That'll tell you how many solutions to expect. If the discriminant is negative, then there's no real solution. If the discriminant is 0, there's one unique real solution. If the discriminant is positive, then there will be two distinct real solutions. Now, the quadratic formula always works. If there are solutions, or at least one solution, then the quadratic formula will always find those solutions. But if you can easily factor the quadratic expression on the left-hand side, then go ahead and factor it. Or complete the square, whatever is easiest. So let's take a look at an application problem. So we've got some square piece of metal here that measures x centimeters by x centimeters. We are going to cut a 9 by 9 notch from each corner, leaving you just with the blue piece of metal left, and the yellow pieces will go away. Now, when you fold this, you're going to fold each side up along these creases to make the sides of an open top box, where each side of the bottom is x minus 18. Okay. So here's what the box will look like. I know that the bottom doesn't look like a square, but it really is a square. Now, what is the volume of this box? The volume is height times length times width, 9 times x minus 18 times x minus 18. Now, we want the volume of this box to be 144 cubic centimeters. So what we'll do is we'll set this volume equal to 144, set that volume, which is this guy, same as this, equal to 144 and solve for x. Now we could solve this equation by dividing both sides by 9. 144 divided by 9 is 16. And then, hey, use your favorite method for going from here. In this case, we can say that x minus 18 is equal to plus or minus 4. And then add 18 to both sides to get x by itself. Now, if you have 18 plus 4, then you get 22. If you get 18 minus 4, then you get 14. But 14 could not be a viable solution. Remember what x is. X is the length of a side of the large square here. But 14 could not be that length because we need for x to be at least 18 centimeters. Okay? If x is less than 18, then we wouldn't have a box. So we would eliminate 14 as a solution and then accept 18. So, or 22, I mean. We'll accept 22 as our solution. As in a 22 centimeter by 22 centimeter large piece of metal square is what's needed so that when you punch out the corner notches, 9 by 9 notches, and you fold up the sides, you'll have a metallic box that has a volume of 144 cubic centimeters. Okay? Ta-da! So the base of this metallic box will be 22 minus 18, which is 4. So 4 by 4 with a height of 9. Okay? And that's it for this section. Okay? So when we come back with the next lecture, we will talk about complex solutions to quadratic equations. Okay? So have a good day, and I'll talk with you next time.